Hello friends, I am Dibrugarh and today I am going to solve this paper of mathematical physics PHYC3A of BSc 3rd SEM Dibrugarh University 2024. Okay, this is part 1. I'm going to complete this paper in 4 or 5 parts. Okay, because if I try to solve the complete paper in one video, that video gonna be very long. Okay, so that's why I'm gonna take 4 or 5 videos. Okay, so this is part 1. So before we start, please do subscribe the channel, hit the thumbs up button, also share with your friends, inspire me to create new contents for you and help me to grow my channel. And if you want to follow me on Insta, this is my Insta ID OJHALAKHYAJIT123. that's my Insta ID. You can follow me on Insta. So now let's start. So here is the first question, choose the correct answer. Okay, so first this option, this question A, options are on the other side. Okay, so here we have a differential equation and we need to find the degree and order. So here you see, if you observe this differential equation, so this is the differential equation, right? This is the differential equation. So here is, if you see this differential coefficient, this is the first order, this is the second order differential coefficient, and the order of the equation is the order of the highest differential coefficient, so that is 2. Here the order is 2, and degree is the power on the highest order differential coefficient. Degree is the power on the highest order differential coefficient, that is the power on this. So here the power is 1. Okay, so power on this second order derivative is 1, so that's why degree is 1. So degree and order respectively, degree is mentioned first, then order. So degree and order, so 1, 2, so option 3 is correct, 1 and 2. Okay, so now let's move on to next question, question number B. So here you see, we need to find the projection of this vector on this vector B. So projection, so let me show you how to find the projection. Just give me a second. Now you see, we know that vector A dot vector B is equal to AB cos theta, right? And A dot B by magnitude of vector B is A cos theta. This A cos theta is projection of vector A on B. There are two terms, on B and along B. So if we want to find the projection of vector A along B, when we used to find that vector along B or in the direction of vector B, then we have to multiply. So now A cos theta, it should be multiplied by B cap when it is given along B or in the direction of B. Now we need to find the projection of vector A on B, so that's why we need simply A cos theta. So here theta is unknown, so we can take this part, we can evaluate this, right? So this is equal to A cos theta. So we're gonna find A dot B by B. Here you see A dot B, so dot product of these two. So I cap dot 4 I cap, that's gonna be 4 I dot I is 1, right? Then you see minus 2j minus 4j, that's gonna be minus plus 8j dot j is 1, right? Then again k cap dot 7 k cap, so that's gonna be 7 k dot k is 1, right? So that's what we have got, divided by magnitude of B means 4 square, this square of minus 4, then plus square of 7. Okay, so now let's find it. So if we calculate this, then what we're gonna get, 15 plus 4, that's gonna be 19, right? Then root over 4 square 16, 32 plus 49. Okay, so 16 plus 16 plus 49. So that's going to give you 19 divided by root over 81, and square root of 81 is nothing but 9, right? So this is what we have got. So correct answer will be 19 by 9. Okay, so hope you have understood. If the answer is given, that if the question is given projection of A along B, then we have to multiply here BK, right? Hope you have understood this. So now let's move on to next question. The next question is vector A is sinusoidal vector, then so a vector is said to be sinusoidal if its divergence, okay, if its divergence is equal to 0. That means divergence means del dot A is equal to 0. Del dot A means divergence, del A means gradient, and del cross A means curl, right? Hope you know these things, right? So divergence is equal to 0, so that's why option 2 is correct. So here option 2 is correct. Now which of the following is correct? Now remember that divergence of curl of a vector, divergence of curl of a vector is 0. So divergence del dot curl del cross A is equal to 0. So that is option 2. This option is correct, right? So hope you have understood this. So this is the next question, question number 2. Here we need to show that limit x tends to 0 of sine inverse sine of 1 by x doesn't exist. So now let me show you how to solve this. So first, you know that limit of a function, limit x tends to a of a function, suppose f of x. So if it exists, will exist if left hand limit is equal to right hand limit, right? So how to find the left hand limit? Now you see, if you consider, so meaning of left hand and right hand limit, that means now you see here, what do you mean by x tends to a? This point is suppose x is equal to a. X tends to a means, so value of x tending towards a, it may be from left hand side and it may be from right hand side. Okay, suppose we have a point here. So if this point is a, then this must be, you know, less than a. That means it may a minus h. And on the other side, so here we have a point a plus h, right? So if you replace this x by a plus h, x tends to a as h tends to 0, right? When h will be 0, x will be a, right? You can say it. So that's why how to find the left hand limit of this function? So left hand limit will be equal to, you know, limit h tends to 0 f of a minus h, and right hand limit will be equal to limit h tends to 0. Here we're going to write f of a plus h, right? So hope you have understood this. Now let me clean these things, and okay, let me write these two conditions here. Okay, so now you see, if you consider this sign of so let me write here. So limit x tends to 0, here 0 is to be considered as a sine of 1 by x. Okay, so let me consider this, let me compare this one with x tends to a f of x. Okay, then here left hand limit will be equal to limit h tends to 0 f of a plus h. Here a should be considered as 0. Okay, so that means limit h tends to 0. So instead of a, we're going to put 0 plus h. Sorry, in case of left hand limit, it should be a minus h. Okay, so 0 minus h. Okay, so f of 0 minus h. That means here the function is sine, so we're going to write limit h tends to 0 sine of 1 by, instead of x we're going to write 0 minus h. Okay, instead of x we're going to put 0 minus h. So that's going to be limit h tends to 0, so sine, so here minus 1 by h. That's what we're going to get. So we know that sine of minus theta is minus sine theta, is minus sine theta, right? Is minus sine theta. So that's why we can write this minus limit h tends to 0 sine 1 by h. That's what we can do, right? So similarly, if you find a right hand limit, then that's going to be, you know, limit h tends to 0 f of, now a plus h. So instead of a we're going to put 0, limit h tends to 0, instead of a we're going to put 0 plus h here. So the function is sine here, so we can write limit you know, sine of 1 by, instead of x we're going to write this time 0 plus h. So limit h tends to 0. So here we're going to get limit h tends to 0 sine 1 by 0 plus h, simply h. So here you see, if you see the difference between these two results, this is the right hand limit and this is the left hand limit. So here we have got negative and this is positive, so which is not equal to the left hand limit, right? So that's why this limit doesn't exist. So what we should write, since left hand limit is not equal to right hand limit, so limit x tends to 0, let me write here properly, limit x tends to 0 sine of 1 by x does not exist, right? Hope you have understood this. That's how we can prove. So if you need vector calculus video lectures on vector calculus, you can visit the link that I have given in the description box. Okay, so I have already made video lectures on vector calculus. Okay, I have given the link of that playlist in the description box. That's gonna be very helpful for you. Okay, or you can search vector calculus by maths tutor Loikhajit. Okay, then also you will get access to that content. Okay, and in this video we have already solved from question number 1a to question number 2a. So from 2b I'm going to start solving from 2b in the next video. So thank you for watching this video. Stay connected. See you in the next video. Bye bye. Take care.